Once again, I welcome you all to the day 3 of the Data Jobs Nigeria Power BI Challenge. Today we have a very wonderful guest. Last week was, very superb, very wonderful. We had Samuel Morunkeji who taught us about Power Query and different ways of transformations. I remembered watching the video again. I saw something interesting about how you can create dictionary, create lists, and all of those, different kind of dynamics or transformations, how you can do groupings, and all of other things I can't even remember now, but very interesting stuff. Today is going to be super interesting too, because we have a very wonderful person who is coming to take us data modeling in Power BI. And data modeling seems to be one of the most important topics in Power BI because the way you build your model determines the output of even your DAX or whatever thing you are visualizing, right? So data model is very important, and a good deep knowledge of data model. Data model cuts across, a lot of things, not only Power BI, even in Excel, even in SQL, even in Python, even in data warehousing concepts, every of those stuff, right? Data model is very, very basic and very important, right? So today we have Ademola Atolagbe. So I'll just read out a little bit about him, what you're seeing on the screen. Ademola Atolagbe is a seasoned data analytics professional with a diverse skill set and over 4 years of experience in designing, building, and deploying data solutions. He holds professional certifications as a Microsoft certified Azure data scientist and AI engineer, demonstrating expertise in cloud-based technologies. He has a strong background in programming languages such as SQL, Python, as well as in BI tools like SQL Server Integration Services, Power BI, and Excel. He has experience across 3 major functional roles in data analytics. He is currently a data scientist at Avon HMO, right? You see the handsome guy on the screen. They will be the one to come and take us data modeling today. So I welcome Ademola Atolagbe. Are you there? You can share your video. At the same time, you can share your screen. Ademola, can you hear me? Okay, let me unmute you. Sorry. I think I did the settings. Yeah. Okay. You can unmute yourself now.
Okay. Thank you very much, Benga. I hope you can hear me very clearly.
Yeah, very clear. Very clear.
Okay, thank you. Thank you very Okay, that'll be nice. Okay, thank you very much, Benga, and thank you for putting together this challenge. I must say I understand how busy you are and you putting this together and having different people talk about the different concepts in Power BI is actually a very good one. It's a way to kind of, demystify the whole Power BI thing, without having to put too much in one session. So it's actually, a very good initiative you have put together to have different people take on different concepts of Power BI. And so today we'll be looking at modeling in Power BI. And like Benga has mentioned, data modeling cuts across, the major different tools. So it's not peculiar to Power BI. As a matter of fact, if your data modeling, concept is good from the very beginning, you would have very little to do about data modeling in Power BI. If you have a very good data engineer or a very good database administrator where you work, and from inception, your data modeling has been well engineered and architectured, then you would have very little to do. But even at that, you have to understand, because that's in an ideal setting. And for a lot of people that have experience already in in data analytics, you would understand that the ideal is not usually the case. I mean, real life data is way different from the data you interact with on Kaggle or your AdventureWorks data. Is usually much more complicated than that. So data modeling is very important. It's the basis for your reports, whether your report will be, accurate or will pass validation or not, it starts from your data modeling. So I would try, because we have very limited time. We have about an hour to finish this session. So I'm going to try as much as possible to be practical, because I want to take you to Power BI and show you all those things. But before we do that, I would want to, let me share my screen. Give me a second. Okay. All right. So I hope everyone can see my screen. Let me know if you can see my screen.
Very
Can
clear.
you
I can
confirm
see
that
your
for me,
screen.
Benga?
Very
Okay.
clear. Very
Okay.
clear.
Okay. All right. So I'm just going to run us very quickly through this slide so that I would have a foundational knowledge of what data modeling is and why do we even need to do data modeling, right? So, we will be looking at, introduction to Power BI data modeling. We'll be looking at understanding data models, the type, the differences, and the different use cases. And then cardinality in Power BI modeling. We'll look at that, and then we'll go to Power BI to, do some practical exercises, and then we can then have Q&A. So that's how this session is going to flow. So Power BI modeling, what does it mean? So it's basically you creating and organizing your data within your Power BI. So that's just basically it. Most times when you want to build a report, most often your data that you need for your report is not sitting in one location. It is not sitting in a single table. And so if you have data scattered across, sometimes you are even picking from different databases. Sometimes you are picking from an SQL server or a database, and you have some other data that are sitting in Excel somewhere. And you have to, you are trying to build a report that would pick information from each of these locations to, for something that you can present that would make decision making easy and get better insight from your data. So with that in mind, it is then important for you to find a relationship between all these different sources of data. And so how you model that relationship to be able to, pull data from different sources and marry them together, it's basically what modeling is all about. And like Benga said at the beginning of the session, it is not peculiar to Power BI. In fact, I usually mention it that if you work in an organization where they have a very good data engineer, your job is half done as a Power BI analyst or as a data analyst. If you have a very good data engineer in your organization, then your work is half done because you would have less headache and you would have more clean data to work with. But in most cases, you will find that most companies would even hire a data analyst before they even start talking about a data engineer. So a lot of the time, you have to understand all these data engineering concepts because there's always that debate as to whether data modeling should be part of, a skill that a data analyst should have. It's more of a data engineer problem. It should be, but we all understand that in most cases, you have to be the data engineer in your own little way, in your own little uh, organization and all of that. You sometimes have to do the work of a data engineer. So if you don't understand data modeling, you're not going to, be able to function properly, even if your role is a data analyst, right? So that idea of trying to marry data from different, sources is what Power BI data modeling or data modeling as a whole is all about. And what are even the importance? Why do we need data modeling? You need it for optimized performance because when you build your report, you want it to be performing optimally. If your data model is not correct, then you cannot optimize your reports. Then you need it for accurate data presentation. You will see when we get to the practical side how important data modeling can be. Because if you get your data modeling right, you can build very beautiful visuals, very appealing visuals, but the information you're passing in your report would be inaccurate if you don't get your data modeling right. Then for ease of maintenance and scalability, a lot of the time you build a report and you build it one-off. You don't want to come back all the time to come and do some minor tweaks. It makes it easy for you to scale. If you build a report and your data modeling is right, even if the size of that report or the size of that table, the data feeding your reports, even if it gets into zillions and millions of data, if you have gotten your data modeling right from the beginning, it's easy to scale your reports. And then for effective resource utilization, of course, we know everything runs on, now that we are even in the age of cloud, technologies where most, your storage is in cloud, your compute power is in cloud and all of that. And it is pay as you use. That's what most cloud technology is offering now. So as a Power BI analyst, you also want to be looking at effective resource utilization in terms of compute. If you have a report that takes over 15 minutes to refresh, when you could have made it refresh in 2 minutes with a very good data model. The compute power for it to run in 15 minutes compared to if you were running in lesser time, you will be saving your company a lot of money if, you do your data modeling right. And then it's also, very, very important is that it helps to improve collaboration and prepare user-friendly reports, right? So let's look at understanding data models. I think I've explained what a data model is. It's just an abstract representation of different data structures and relationships within a data set. I've mentioned that. I'm not going to belabor that fact. And then we have the different components of in data modeling. So you have your tables, different tables from different sources. You would have your columns, you have your relationship, and sometimes you have to refer to the metadata that will define how your data is stored and how they are connected or how they interact in Power BI. So let's look at the different type of data models that we have. So, globally, we have two major types of data model. Whether you're doing Power BI or even if you're designing a database or you're, designing a data warehouse, there are two major types of, data models. We have what we call the star schema. And just like the name says, it's just, for you to understand this, I would have to explain what we call a fact table. So in dimensional modeling or in modeling, we have what we call a fact table and we have what we call a dimension table. So the idea of a star schema is that your fact table, your dimension tables are tables that have specific information about a specific business attributes. Let's say, for example, we are looking at a bank. What are the things that you can store, the kind of information you can store in a dimension table? One of the very key attributes of a dimension table is that it stores particular information about a particular business entity. For example, if you pick a customer, a customer is an entity in a bank, for example, or any business. A customer is an entity. Information about customers will be stored in a dimension table, right? And so it means that when you go into your what we call your DIM customer, for example, that's your dimensional table of your customers, you will find, if you pick a particular record, you will find information about that particular customer in that table. Your product, the kind of product that you're offering, you want to store information about that product, that would also be in a dimension table. So dimension table, they are not information that changes rapidly or that gets updated very fast. That's one of the very key things to know when you are trying to say, oh, which information should stay in a dimension table. So a dimension table stores information, and those information are not information that are getting updated very quickly. So, and that's why, if anybody has heard about slowly changing dimension, that's why if you are doing if you're trying to design a data warehouse, you use your slowly changing dimensions, you use them on your dimension tables. So a star schema means that a fact table, so let me explain what a fact table is. A fact table will store information about your transactions, your sales, your account transactions and all of that. So fact table stores information about the core part of your business. You can imagine a bank, a single customer can do, can do like up to 20 transactions in the space of like 5 minutes. And all of those transactions has to be stored. And so it is usually stored in your fact table. So you can have a customer, a single customer, having multiple records in your fact table. Your dimension table would have only one record about that particular customer. You want to keep your customer's date of birth, their marital status, their email, you keep them in your dimension table, and then there's usually a key, what we call a primary key in your dimension table, and that is what will now connect to the fact table to say customer 100. Let's say we attribute a key of to one customer. And so we can come to fact table. And when we are referring to that customer in our fact table, we are not taking all maybe the customer name, email address. You will not find them in the fact table. You only find that key, customer 100 or customer 120, perform this transaction, customer 112, perform this transaction, and like that. So if you now want to get more information about your customer, you have to refer to your dimension table about the customer. So I needed to provide that context so that you understand dimension table and then fact table. Fact table is storing information that is rapidly getting updated or changing in your business. So, and for star schema, it means that you would have a fact table right in the middle, and then you have different attributes of your business connecting to it as dimension table. That's the star schema. There's a direct relationship between your fact table and the different dimensions of your business. And so it's looking like a star. Fact table in the middle and your dimension table connected to it like that. So the next one is the Snowflake schema. And this is an extension of the star schema. But so in some cases, for example, this is usually in big databases where they are trying to reduce redundancy. I mean, for example, now you have a table for your product, but for the product table also has like a sub categorization in that product table. And so there are informations that are connected to your dimension. Your dimension table is connected to another dimension table, connected to another dimension table, and then before another dimension table is now connected to your fact table. So you can see an example here where we have your fact table and then connected to all these dimensions. But you can see that these dimension table are also now connected to another dimension table because there is a relationship between this dimension table and all those dimension table that is now that you need to reference when you're doing your reports. I will show an example in a database that I have so that you'd understand what that actually means in real life. But this is what it looks like. So your star schema is fact table connected to individual dimensions that has reference in your fact table. Your Snowflake schema is connected. Of course, you have dimension table also connected to your fact table, but you now have your dimension table also having connections to other dimension tables to give more context to your data. So I'm going to show an example of how this Snowflake schema works by showing you something in the database. But let's quickly look at the differences between your star schema and your Snowflake schema. So in terms of structure, I think I've explained that. Central fact table connected directly to multiple dimensions table. But for Snowflake schema, you have your central fact table connected to dimension table, which are further normalized, that is further connected to other multiple related tables. For complexity, it's easier to design a star schema because you are dealing with very few tables and very straightforward relationship. Fact A is connected to dimension B. Fact A is connected to dimension C, also connected independently. So even looking at it is easier to manage other than what we have in Snowflake schema. Because that one requires you doing a lot of joins. You are joining one table to another to make reference and all of that. So it's easier. Star schema is easier than Snowflake. But in terms of query performance, you would have faster query performance in star schema because it's easier. I mean, it has very few joins, and so you can easily, your query would work faster when you're dealing with a star schema than when you're dealing with a Snowflake schema, but because you have multiple joins, and when you have multiple joins, your query will take longer to run. And then storage. Unfortunately for star schema, with all of these advantages, it uses more storage. And I'm going to show why by quickly just going to a database and showing you why, because it's usually denormalized. Let's say, for example, we have like a carport where they sell different brands of cars. And so you store information about, for example, now you have Toyota, you have Honda, you have Mercedes and all of that. And you have a table that speaks to this, your product. Now, if you want to design that table in a star schema and you want it to have only just one product table, it means that Toyota has other different kind of types. Toyota is a brand, and then under Toyota, it could be a Toyota Camry, it could be all of that. It means that for every car, you must have a record of that car in your what's it called, in your product table. So what the difference, what star schema does for you is that what it will do is that it will now split those tables into several tables. For example, now the reason why it uses more space, star schema now would try as much as possible to say Toyota Camry, give it a code and store it in my table. Toyota Avalon, give it a code, store it in my table. So for Toyota, you may be having, maybe they have 20 different types of cars under Toyota. You must store each of them like that. And it would cost more space. Other than if you use Snowflake schema, for example, what you would do is to just say Toyota, give Toyota a code. Toyota, Mercedes, that would be like your product table. You bought a Toyota, bought a Mercedes. You now create another table that would now say, oh, you have a product subcategory where you are now saying that, oh, under Toyota now, we now have Toyota Avalon, one record. Giving it a code. Toyota Camry, one record, giving it a code. So if I want to make a reference, if I'm querying my database and I've seen, oh, I bought Toyota. If I want to query further to know which kind of Toyota that I bought, the only thing that I will have to do, because I have done my data modeling by creating a key that speaks to Toyota, I can now go into the other table that was created to say, joined by the key that is common to both, to now say which uh, Toyota was actually bought. So you have less storage when you're using Snowflake schema because it normalizes your data. And instead of having multiple information in one table, it breaks them down and create another table that is now only joined to that table by a key. So it saves more space, right? And star schema is easier to maintain than because there are fewer tables and relationship, uh, more than you have for Snowflake schema. And then the use case is for star schema, if you are dealing with a small to medium-sized data warehouses, star schema is good. You don't really have to worry too much about space like that. So you can create your star schema where you store each information. Toyota, Camry, you can store them one line. I mean, Toyota Avalon and all of that. But if you are dealing with a very big database, for banks, for example, where they have millions of customers and it's best to use your Snowflake schema, right? So so we'll move on to cardinality in modeling. That's also one very key thing that you have to understand. We have different cardinality in Power BI modeling, and we have one-to-one, which means that if I have, for example, if I have a product, so I have a product table and I have a product category table, and I have just one instance of this SKU, which is the unique identifier here. I have one instance of it in my product table, and also one instance of it in my product category table, it is usually a one-to-one relationship. It means that one record in product table can join to a single record in product category. Is one-to-one. The one you would experience more is one-to-many and many-to-one. That's what, that's what you would see more in most of your report. One-to-many is looking at you have one, for example, you have a customer table and you have a sales table. Like I explained, your customer table, you have one customer key representing a particular customer. So all information about that customer is stored on just that one line of record. So you have one customer, but in your sales table, of course, it's possible for a customer to make multiple sales or to make multiple orders. So you would have more instance of a single customer key. It's most likely that it would appear in more than once in your sales table or in your transactions table. So that is one to many, means one customer making multiple sales. That's one-to-many relationship. We also have many-to-one, which is like the direct opposite. So it's just changing the position of the tables. In this case, if I bring my sales table to the right here and take my customer table to the left, it becomes a many-to-one relationship. So it's the same concept. Then we have many-to-many. So you have many instances of this record in this table, and we have many instances of that record in the other table as well. We'll look at examples. So let me go to Power BI. BI. Yeah. All right. So while that is open, I wanted to quickly show why that is open. Let me show this database very quickly. So I use that to explain. Now I'm sure most of us here would be familiar with the AdventureWorks database. For anybody that has done any practice in Power BI, most likely have some. Okay. So for anyone who have had any form of practice, you'll be familiar with this database. So let's look at these three. We have DIM products, we have DIM product category, we have DIM product subcategory. And using that to quickly highlight the difference between a Snowflake schema. So it is possible to combine these three tables into one if you want to do a star schema, it means you have to combine these three tables into one. This is definitely a Snowflake data modeling. To have the product, you now have the product category, you have the product subcategory. Let me pick very quickly just to recreate this point so we have an understanding of data modeling right from your database is where you start your data modeling. If your data modeling is done right from your database, you would have very little to do from your Power BI. So I'm going to run this and I'm going to show off this table. So let's look at this. So this is the product name. We have product key here. So for every product that this particular company is selling, they have all this information here. So this is the name of the product and this is the key. Now, if we scroll down and look at the information in the product category, so we can see that we have a key here, product key, and we also have product key here in product category. And then they are now breaking down the categories into bikes. There are only 4 records in this table. There are 4 records in this table. If we want to force this into a star schema, it means that in this our DIM products, we are going to now have like times 4 of all of the records that we have here. because it means that if we want to have this category also in our DIM product, it means that for every product that falls under bikes, you would have repeated, you'll be seeing bikes repeatedly as a record. You'll be seeing it. So it will be multiplied, but you have more records in products that way. And that's why it takes up more space. You just have 4 records here. So if you want to make reference to this table, all you have to do is use their product key and join them together instead of having them in your DIM product, which would make the size of the table bigger. The same thing with this subcategory. So under subcategory now, we now have whether it's chains. So you can link to whether it's bike first, and then before you can now get to the particular product. So it means that if you want to add this one even to the product as well, you would have to do that. It's not, I would have, because sometimes even when your database is designed in a Snowflake manner, and if you have knowledge of SQL, in building your report, you can force your data into like a star schema before you even import it into Power BI. So what I will do is I'll pick all the information that I need here using join here already, and then I will import so that I don't have to do Snowflake schema in Power BI. So let's go to our Power BI so we can, put into practice some of these concepts that we've been talking about. So of course, I know the last session, first session, we looked at importing data into our data query, into our environment. So I'm not going to talk too much about that. And we've also looked at data transformation in Power Query. So just going to, I want to assume that everybody knows how to connect to your different data sources. The beauty of Power BI is that it allows you to connect to, an exhaustive list of different data sources. So, which works. Right? Okay. So I will be importing this data. So let me see, I'm going to, this is a proper data warehouse. You can already see that your data warehouse have been designed for you to easily identify what are dimensions and what are facts. Like I said, if you are familiar with AdventureWorks, you would have seen this. So you have all your dimension tables starting with DIM. Yeah, so this is an ideal case. For anyone that has experience here, you know that most of the time your database that you're interacting with, you have to figure out which one are dimension. I must also mention that it is very, very important before you can do a proper data model, you need to have an understanding of your data. You must know your data, because if you don't know your data, there's no way you would understand the relationship between the tables. So you must familiarize yourself with the data. If there is a data dictionary for that warehouse or for that database, you need to go through it first before you can perform a very do a data modeling that will be efficient. So I'm going to pick DIM product. I'll pick DIM product category. And then I would also pick this fact internet sales, which is a fact table. I will build in customer in geography, and then I would load. Okay, so I wanted to show something even before I would let's this finish loading, and then I would quickly highlight a setting, although it's usually by default, but let me see. So Power BI has an inbuilt function that automatically detects relationship between your data. And that's why I said that if you have a good data engineering in your team, it gives you less headache. Because for this data, if the keys that you have in your different tables, if they have a similar naming convention, Power BI can automatically detect relationship in your data and create that model automatically. But it's not enough to say, oh, it has created it automatically for me, and then you start building your reports. You still need to check and ensure it fits with the understanding you have of your database, right? So this is almost done. Okay. All right. So I want to quickly show this. Okay. In case you're working with data that, I mean, with Power BI that does not have that setting as default. So you can go to options and settings here, go to options.
Sorry, Ademola. Hold on.
And
Somebody's raising their
yes,
hand. Please, if you have any questions, please just write it down. There will be a section for Q&A after all his teachings, so that we don't use that to waste time. If you have any questions, just write it down. At the end of the class, you can ask. Thank you. You can continue. Continue now, Ademola.
all
You
right.
can continue.
Thank you,
Okay.
Benga. Yeah,
Yeah.
so please just note down your questions. I will take them at the end of the session. So let's just run through and then I can take the questions. So here you can come to data load here under sessions and you will see relationship. Import relationship from data sources on first load, auto detect new relationship after data is loaded. So you can ensure that these two are checked so that when you load your data, that relationship can, and for some people, they don't want Power BI to do the data modeling for them. You want to be able to import your data and do your modeling so that you're not confused by what Power BI has done for you. So whatever works for you, you can check or uncheck those two settings here, and then that allows you to, whatever works for you. If you don't want it to be auto-detected, you can uncheck this one, and then Power BI will not auto-detect relationships. So I've imported 4 different tables now. I'll go to my model view. This is where you would see the relationship. Because I have the auto-detect checked, you can see very clearly here that my uh, my model has been created automatically. So you can rearrange. You can be wondering, is this a star schema or a snowflake schema? You can rearrange these ones as you please. And yes, so you have your fat sales, you have your team product and all of that. I mean, looking at this already, this is a snowflake schema, because you have your fat sales here, joined to the product, joined to the customer, but there's no relationship between fat internal sales and the geography. There's only a relationship between the geography and the customer. And so that's why you can see this relationship. So this is a snowflake schema. If I want to ensure that this is a star schema, maybe I want to ensure that some people prefer using star schema. And I mean, you can do this either in your data transformation. So it's possible for you to have looked at your DIM customer. What is the information that you want in this DIM geography? Why did you bring the table? Because you don't just import table into your environment. There has to be information sitting in that table that you need. And you know that there's a relationship between the customer and the geography. If I want to ensure that my modeling is a star schema, then either in my data transformation in Power Query, I would have merged this with the customer to pick only the information that I want from the geography. The geography has a lot of columns here. It may be that I just need just 2 columns from this geography. So if I know my SQL, I would have written a query that would ensure that that information has been brought in to my DIM customer, whether it's the postal code or whatever it is that I need. Or I would have done it in my Power Query to merge the information that I want. And so this one becomes one single table when I'm here in my modeling. But this single table here has made this modeling a snowflake schema. So the cardinality that I spoke about, so you can click on any of this relationship, and this one would give you information on the right side here. You can see the table name is fact internal sales, and it is column that you're joining on is customer key. This is a many-to-one relationship. It's a many-to-one relationship. And what that means is that, so if you look at it, I mean, the fact internal sales is the first table at the top. So in the fact internal sales, you have many customers making multiple sales. And so that's why it's many to one. There are many customers, but in your dim customer, there is just one customer, one record for each customer. So it's a many to one relationship. And this cross-filter detection is a single one. I will show you the impacts of this one, whether you're using a single or you want to use both. Because what it means is that it's a single direction relationship. Fact internal sales is only connected to the customer one way. It's not both ways. It means that now, if we have DIM product here, there's no relationship between DIM customer and DIM product. I might have some information in DIM customer that I also want to visualize. I may have some information in DIM product that I want to be looking at from DIM customer. I will show you an example. Let me quickly do this, and to show an example of that, let me bring in a table here and say I want to look at customers. So I want to look at customers, each customer, and look at how many products that they ordered. How many unique products did they buy, each customer? So I can come here and go to my DIM customer and pick, let me just pick customer first name. Uh, first name, yeah. Okay, so I pick customer first name, and then I now want to also go to DIM product and pick count of English. Okay, so count of product. This one is, I'll change the aggregation to count. Come here and change it to count. Look at what has happened here. You can see that it's picking Aaron, for example. Let me see if I can, I'm not sure. Can you confirm if you can see this, if this is not too tiny? Okay, I've expanded it.
It's clear.
Yeah. So you can see that the count of English description is just 396, everybody. And so you begin to see the importance of your data model, because if you present this is wrong. And the reason why is because there is no direct relationship between your DIM customer and DIM product. This is your fact internal sales is what they are both joined with. But with your modeling, it is possible for you to have this kind of information broken down the way you want it, because what you want to do is to see how many products is a particular customer, how many unique products each customer is buying, right? So to take care of that, what I would do, and that's where this cross-filter direction comes in, I have to make the relationship between the product and fact internal sales, I have to make it both direction. What that means is that it will kind of create for every order that we have here, every product key that it sees, it would also kind of mirror all the information that we have here. So it means that I can pick information from here, despite the fact that there's no relationship, direct relationship between DIM customer and DIM product. I can filter my DIM customer by what I have in my DIM product. So let me come here and change this direction to both, apply changes. And then go back to this report. You can see now that you have a representation. So you can see each customer, the number of products that they actually bought in your sales data. So if your data modeling is not right, you would be presenting something that is wrong. And so you have to understand when to use this or when to not use both directional relationship. So if you're trying to connect tables that are not directly related, but they have a fact table that relates both of them, then you can ensure that you have a both bi-directional relationship between the two tables, so that you can filter by what you have in that customer table, you can filter by that, you can see that we did not pick anything from our fact internet sales. We pick name from customer, the customer, and we pick counts of product name from our in product. So this is filtering the fact internal sale, which is our sales table, despite that we are not picking it directly from there. And so those are the, very key importance of, doing your modeling right. And like I said, there's no one way to do this. You can ensure this relationship is defined right from your transformation. I'm sure if you were part of the other class where transformation, most of these things would have been shown, how you can ensure that, in fact, as a matter of fact, you can even in your data transformation, in your Power Query, I can ensure that I only have one table that eventually gets here, because I would have created a relationship, bringing everything I want from my DIM customer into this fact internet sales, bringing everything I want from my DIM product into this one. And then I come here and I have a single table and I don't have to do any modeling. But it doesn't work in all cases, because imagine if you are dealing with imagine if this fact internet sales is already, maybe you have about 5 million records in there, and then you now want to bring in 5 million records of sales. You already have it here. You now want to bring the customer information again that would replicate all the information you have here 5 million ways. Replicate all the records you have here 5 million ways. And that's why star schema, if you're trying to force your modeling to star schema, then you should be ready to have, incur more cost on storage. And that's why you see some Power BI reports, you will see them, you will be running into gigs, some for 500 MB. Some of it is from your modeling. If your modeling is not done right, then you would have, you would have to sacrifice space and sometimes the performance of your report and all of that. So again, another thing that people try to do, I'm trying to create, look at many-to-many relationship. Let me look for a table here that would have that relationship. So let me bring in another table. I'll bring in another table very quickly. Okay, so page. So I'm going to bring in, let me bring in, so I'm going to bring in this and bring in, yeah, so I'm going to bring in this table very quickly. So for one-to-one relationship, okay, I should bring that. So one-to-one, like I explained, it just means that you have one record in here that is mapped to only one record in the other table. It's very rare. I mean, the one that you would encounter most is this one-to-many or many-to-one. As a matter of fact, I mean, we try as much as possible to avoid many-to-many relationship because it comes with its own uh, complexity when you have many-to-many relationship in your data model. In fact, when you're trying to do many-to-many relationship, there's a warning that pops up on Power BI to alert you that this is going to have a many-to-many relationship, and do you want to go ahead and do that? Let me try this. So this fact internet sales reason, there's sales order number here, and there's also sales order number in this table, sales order line number and sales line number. So I'm going to join this. to this one. So you can create that relationship like that. Says other line number, says other line number. And this is a many, you can see the mapping, many to many. This one cannot be one to many, or it has to be a many to many, because you have multiple says other line number and multiple says other line number here. And so you can see the warning that it has brought. It's not that it's not stopping you from doing it, but it's this relationship has cardinality many to many. This should only be used if it is expected that neither column contains unique values. So once you know that they don't have unique values, that's when you can use many to many. In this particular case, you can avoid this because we have a dim sales reason. If you look at the database, let me quickly, this is a dimension that is detailing information about the sales reason. So we can avoid this many-to-many relationship by connecting the sales reason to that particular table instead of doing a many-to-many relationship, right? So, and then, once you are okay with it, you can also have it both way, or you can have it single. That means fact internet sales filters fact internet sales reason, or fact internet sales reason filters fact internet, or you can have it in both direction, just like done. And so you can see it has created that relationship. You see star to star is many to many, star to one, many to one, then one to star, many to one to many, and then you have one to one. So I think that's about it for data modeling. That's about what I have. I will start taking questions now. If you have any questions, you can, Gbenga, you can go ahead with
Okay,
the questions.
Ademola, thank you so much. I really appreciate your presence here today. I have some few questions. There are some that I'm going to ask for those that I know
Yeah,
that
please go ahead.
yeah. Can you hear me clearly? Can you hear me clearly? Hello?
Yeah, I can hear you. Go ahead,
Okay,
Gbenga.
okay, sorry. Yeah, I say thank you for
Yes, I can.
being here once again. And I really appreciate it.
Yeah, Gbenga, I can hear you.
Okay, yeah. So I have some questions, right? Some I'm asking for people that are enthusiasts, and there are some that I'll ask for myself.
Okay.
So the first question I have is, if I have two fact tables, or more than two, or even more than, if I have three or four fact tables, how am I going to deal or aggregate that in the context of data modeling? Let me answer. So let me say that that's like my number one question. Did you hear me? Hello? I think it's a network. Hello,
Okay.
can you hear
Okay.
me?
So if I get your question, yeah, I heard you. So you're saying if you have more than one or two, more than two fact tables.
Yes.
Hello. I
Yes,
think there's a
yes.
lag somewhere there. I
Okay.
can hear you very clearly, but I think there's a lag in you hearing what I'm saying.
Okay. So I said, how do you aggregate
Okay.
two or three fact tables
Okay.
in the
So,
context of data
okay.
modeling?
So I will go ahead and answer that question. So if you have more than one. Okay. All right. The line is breaking, but I think I understand your question. Look at the example that I've done here. So of course, it's possible for you to have more than one fact table in your data modeling. And the concept of modeling, or data model as a whole, is that there has to be a relationship before you can even start any model. So if you have a fact table that has a relationship with another fact table, then of course you can join them together. But then what that does is that you can no longer have a star schema in that instance. So you can have a fact table joined to another fact table, and another fact table even joined to another fact table, and then the fact table joined to another dimension table. So it depends a whole lot on the kind of report you're trying to build and the kind of, visuals you hope to recreate. So you can have fact table multiple up to 5. I mean, there's no limit to it. I've seen some very, very crazy models that you will look at it and you will immediately start to, have headache. And this usually happens in cases where maybe, especially all these legacy apps, that maybe in the design of the app there was no data person there. The developer just did what works and then leaves the headache for people, the data people, to try and now make sense of all the different, aggregate data from here. It was not properly modeled. So I've seen very crazy models, but the key thing is that once you have an understanding of your data, and I can never, I don't think that can be overemphasized, that you need to understand your data. If you don't understand your data, you cannot do a proper data model. So if you have fact sales, if it is possible that the information that you want to pick from that fact sales, maybe it's possible and it's not going to complicate your data. You could have done that in your power transformation and bring it in instead of having multiple fact tables on your model. But if you're dealing with very large data, sometimes you don't have a choice than to bring in that fact table. Imagine if you have fact table that has 5 million record or millions of record, you have another fact table, millions of record. If you try to force them into each other, you would have, an overhead in terms of your storage because your report will now be bigger, now become bigger. And that's why Star Schema takes up more space. So you can have multiple fact table, understand the relationship between them, and then you can model them and join them together. If there's a direct relationship between the fact table, you can join fact to fact, just like I have done here. I've done a fact internal sales with a fact internal sales reason. These are two fact tables. So I don't know if that answers your question, Benga.
Yes, I have another question, but let me allow people
Please.
to ask their questions first. So let me
Okay.
give Godwin the opportunity, and I'll give Loye to the opportunity. So let me start with Godwin.
Okay, good evening, everyone, and good evening, Benga, and good evening, our awesome facilitator today. I like your presentation, and because it is well detailed and very, very explanatory.
Please, can you move away from
So,
that place you are? There's a lot of noise.
okay, is it better now?
Yeah.
Yes,
All
it is.
right. Okay, so my first question is, when you try to load data to Power BI, there's always this
Yeah.
warning that comes up that apply is it pending changes to your data or stuff. It's always
Yeah.
so do you is it advisable to always discard them or apply the changes that were there before? Sometimes it comes even if you are loading data, a new data set for the first time, or you are starting a new work. It just pops up that apply pending changes or discard pending changes. So what is that thing, and how do we go about it? Then the second question is, the complexities you explained in this data modeling today. I do understand that, from what you are saying, if the modeling is not done right, one might have issues with his when trying to display some specific kind of information on your report. For example, the many to many relationship which you explained last. So, what is the relationship between database normalization and this modeling? Where does it comes into play? Is it that it is what is causing all these complexities sometimes, or what? Where does it come into play? Those are the two questions I have. Thank you.
Okay. Okay. All right. Thank you. Yeah, for the first question, when you have those pop-ups that is telling you that you have pending changes on your report, it usually happens when maybe in the middle of your report, do some modifications, especially when you go to Power Query and then you do some transformation. Or it's possible, there are times when it's even from a report that you have worked on previously, that you've applied some changes and you have not updated that information. So that pop-up comes. If you go to your transformation on Power Query and you come back to your environment, whatever it is that you did in transformation would not apply to your data yet until you apply that update. Because the data that you have in your environment will be as at the time before you go to your transformation window, to that window editor to go and do whatever. So by the time you're coming back, it's asking you, should you apply it now or you should. Well, so every time you open that report, it'll be telling you have a pending change on that report until you apply it. So if you discard it, it means that whatever it is, for whatever reason, that change that you have done, you've discarded it. You have to go over and do it again. So that's why. So if there's any change in your data, or you change anything in your data source, or you do any transformation, that pop-up will keep coming until you either apply or you discard it. So the one that you see when maybe you're just loading data for the first time, I don't know if that is, if that is possible. It can only be possible if you have opened a report before that you have not applied changes on. So that's it on that one. For your second question, the complexity. So normalization in database design, what is even normalization? Normalization is what is actually done to reduce redundancy in your data. And I try to explain that using the example of you have a product and then you have a product category, and maybe you now have a product subcategory. Some other database designer or data engineer can put all that information about your product in one table. But in a normalized database, you would not have that information in one table. You would have it in 3 different tables that you can now join by keys. And so what that does is that it reduces redundancy, which is keeping repeated information in a table. Because for example, now if I sell bikes, if I have a product category that is bike, and under bike, I have maybe different parts of bikes and all of that. It means that if I want to store that particular information that product information in a single table, I must have different layers that is speaking to bikes. I would have bike, and then I will now have another column that will now say, okay, maybe it's bike tire. I will go again, create another record. The product category will be bike, and then I will have maybe the on of the bike, and then bike again. So you can have different. So instead of having repeated information, bike, 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 I will go and create another table that will give one key to bike and say bike is an entity, just one attribute in my data. And so anytime I want to know the product that is bought under bike, I will only need to make reference to the subcategory table that will now have single information about that particular product. So that's what normalization is. It's just to reduce redundancy in your data, keeping repeated information in a single table. Instead of just, if I have 4 different categories of product that I'm selling, I'll just have bike, motorcycle, tricycle, cars. And then if I have product under it, I'll go and store that in another table. And then I can now make reference. So that's what normalization is. So depending on what works for you, I've mentioned it that if you're dealing with a very large database, you are dealing with a lot of data, it is best to design your database in that manner, where you normalize your data to reduce redundancy, because again, it would reduce storage space and it creates, easy relationship for you to manage. It makes it easier to manage that database as information gets updated and all of that. So I don't know if that answers your question. So as it pertains to Power BI, it is what is most times your Power BI modeling will conform with what your database modeling is. In most cases, as you can see here, this one auto detects relationship. So if you have a Snowflake design in your database, it would most likely adopt the same design. But the reason why this knowledge is important for Power BI analysts is because you can then say, oh, I don't need my own Power BI model to be Snowflake. I can make it a star schema if I want, because then I can pick the information I want in the product and join it together with what I have in the product category. Those columns that I want, I would have brought them in. Even though the database designer separated them, I can join them together before I even get here. So I can have my star schema. So depending on what you're working with, the complexity and the size of data you're working with will determine how you design your report or the model in your report. So that's it.
Okay, thank you, Ademola. Mr. Akinloye I think he has a question.
Okay, thank you, Mr. Ademola. So it's more like a contribution to the question asked by Mr. Binga about the multiple facts tables. And I'd like to get your opinion and your professional knowledge on this. I mean, when you have multiple fact tables, that share common dimensions but are not directly related to each other, something similar to what you just said. Is an ideal scenario would like when you create, can you create like a bridge table that can connect these fact tables through a shared dimension, and thereby you can have your star schema in your modeling? Would that be a good idea? Because I have I encountered such situation recently, and that was how I resolved that by creating a bridge table. And I think creating a bridge table too can help resolve these many-to-many relationships that can come up. What do you think
Yeah.
about
Yes, I think I would see it as more of a contribution because that question you've provided the solutions to it. Yes. So to avoid many-to-many relationship, I mentioned it the other time that instead of me to have this many-to-many relationship, I can have a connection because we have on our database a dimension table that is connected to this one and also connected to this. So I can have a dimension table in between this one so that way I don't need to have a many-to-many relationship with this table. So yes, it's good practice to do that in order to, avoid a direct connection between your files because most times the scenario where we have many-to-many relationship is when you're trying to join a fact table with a fact table. So if you can create or if you have that kind of table in your database that can serve as a bridge that has a relationship with each of the table, then you can have them here instead of having this kind of situation. Yes, so that actually works and it's a good solution to that issue when you encounter it in your report building.
Okay, Jidara.
Okay, thank you very much, and good evening, everybody. Thank you so
Yeah,
much for
Benga,
this section.
can you hear me?
Yes, can you hear me?
Okay. All
Continue,
right.
Jidara.
Okay.
Yes. Oh, okay. Oh, I'd like to say thank you for the section. My question is, in a case whereby you have a fact table and a
Yeah, I can
dimension
hear
table.
you, although it's breaking, it's dragging a bit, but you can go ahead.
Okay, is it better now? Hello, can you hear me? Hello?
Hello, Mr.
Hello?
Ademola. Hello, Mr.
I'm,
Ademola.
I'm sorry, the line, your line is.
I guess it's your network. Oh. Jidara, just hold on, please.
Okay, sir.
I guess it's his network. It's hanging.
Relationship that I did. Now, I mentioned that when you do that both directional relationship, just picture it like this is because I did a let me see if I can minimize this. Okay. Not okay. So the reason why I was able to do that is because when if you do a bidirectional relationship between your product and fact internal sales, what would happen is that in the model, behind the scene, what would happen is that every record here, there's product key here that is joining the product here. So it means every product key, every record that you see here, it would also kind of like create the same instance of all the things in the product inside this table. Because now we have a cross-filter relationship. If we have a bidirectional relationship, what we are saying is that I can pick a particular product in this table and see the sales amount. Sales amount is not in the product, right? But if I pick, because I have a one-way relationship with them, I can pick the product here and see the total sales amount for that particular product. So if I make it bidirectional, it means that I can also pick a product key here and, see the number of colors and maybe if I pick color or class or anything, I can filter this. Fact internal sales can also now filter the product. And because we have a relationship between the customer and fact internal sales, it means whatever I pick here, there is a customer key that is also here in fact internal sales. So it means that if I pick a customer name, just like I have done in this report, if I pick a customer, Aaron, and I pick English description, which is like the product name, and I'm saying count each one. So it is looking at fact internal sales, although I am not picking anything from fact internal sales. It is looking at it because fact internal sales and products have a bi-directional relationship. So I don't know if that explains or answers your question. So yes, if I don't have that bi-directional relationship, then this would not be possible. It means everything that I want to filter in my customer table must come from my fact internal sales, because I don't have a relationship with products. Products only has a relationship with fact internal sales. Customer has a relationship with fact internal sales. But by making it both, it means I have created a relationship between fact internal sales and product as well, which makes it possible for me to filter the other tables that are connected by things that are inside the product.
Isaiah.
All right, sir. Thank you. Okay, thank you so much so far for all that you've done and for giving a very comprehensive explanation. I just have a few questions. There was a time somebody asked a question on views, but I'm not sure if it's the same question I have. But it still has to do with views in SQL. If you create a views in SQL, views are virtual table, you create them in SQL, can you easily bring that results, because bring that table in views into Power BI? That's my first question. Then the second question has to do with somebody talking about a bridge table. Maybe I don't understand the concept of a bridge table when you were explaining many-to-many relationship. You were saying something that I think the person said that one of the ways you can avoid many-to-many relationship is by creating a bridge table. So I don't know, maybe I need a better explanation on what a bridge table is. Thank you.
Okay. All right. So what we mean by, for lack of a better word, by bridge table is that, in modeling, there are some things that it is not like it is wrong, or if you understand your data, you can model your data, you can do your model any way that you like, but there are best practices. We try as much as possible to avoid a fact-to-fact relationship in your data model, because it creates a many-to-many relationship. And apart from that, it's, creates some kind of complexity in your data. So to avoid that is why we are saying that if it's possible that in your fact internal sales, for example, in this case, there is a dim sales reason table. I think I showed that the other time. There's a dim sales reason table. that has a relationship here and has a relationship here. So instead of having this fact table join directly to each other, you can use that table. Or in some cases, depending on the kind of project you're working with, you can create that table. You can also create tables in Power BI. You can create table. I mean, sometimes it's even a date column that you would use you will create a dim date, maybe a time intelligence table or a date table that you have created in your data model that will now be the bridge between your fact tables. It happens like that. So it could be anything. It might be an aggregation that you have done on your data that you want to do be a bridge. Different scenario calls for different measures. So the idea is to avoid a fact-to-fact relationship. Like I said, it is not like it is something that you cannot do, but it is something that we try to avoid if it is possible. So if it's possible and it's not much, it's not going to add much complexity to your model, you can create a bridge between your facts. So if you join a fact table to that bridge and the other fact table to that bridge as well, you can cross-filter whatever information that you want in both fact tables without any issue. So that's it. The other question that you ask about view, whether you create, views in SQL is just like you writing your query. So instead of bringing the whole query, because sometimes you can write very long queries and all of that, and it is something that you're going to be needing all the time, it's better created as a view. And so you can just, instead of actually importing via query, a view is just like a virtualized table. It is not storing data, but it is storing kind of like the query that you have written. So every time that you run that query, it gives you the results of that view. So yes, you can use view to import your data into your environment as you wish. So yeah, so that's something that you can also do. Yeah.
Good evening, and thank you for the section. So I want to ask a question. In creating a modeling, is it advisable to always place it in both so that you'll be able to connect the tables that do not have relationship to be able to get
Always
this?
place it in what? I didn't get that. Can you say that again?
I said is it advisable to always place it in both so that you'll be able to, because you were able to connect the facts, the customer table with the customer table with the product table by getting the results, the actual result for numbers of customers that actually sent in their like a request. So, but you're able to do that when you placed it in both. So my question is, when writing a model, do you think that is the best format to always place it in both, or maybe if there is a need for us to do something like what you just did now?
Okay, yes. If there's a need to do it, so that's why I mean, the understanding of course, for every report that you're building, you need to have requirements. So if I don't need now, I would say here, I just use that to show an example. I don't need to place this in both, because if I want to count the number of product that each customer is buying, I can get that information in my fact internal sales directly. I don't need to have this relationship in both. I don't need to reference my the product before I know the number of products that a single customer bought, because I can actually do that here as well and say the customer, select whatever information I have here, first name, and then go to my product key and count the number that is attached to each customer, which is what that chart, that table did. So, but in some cases, it might be that that information that you want to aggregate or you want to show, it is not available in your fact internal sales. It is only available in your DIM product. For example, now, I don't have color here. I have color here. If, let's say color is an entity that I want to visualize, but I don't have color here, this is where I have the color attribute. And I want to filter it by my DIM customer. So if I have a bi-directional relationship in this one, then I can have, so it depends on what you want to do. If you want to make it an habit to always put it both ways, that's fine. But when you're dealing with, especially when you have a Snowflake schema, if you place all your relationship in bi-directional relationship, it would create some kind of problem in your report. So understand what you want to do, and that would determine, a lot of the time it's even after you build your report or you visualize that table, you just know that something is wrong. Because by the time I created it and I saw that each customer is the same number across, and then I realized that I'm picking it from the product, then I know that I have to come back here to make it a bi-directional relationship. So there's no one way fits all in this. Know what you want to do, and then understand that this option exists for me to use if I want to use it. Right? So that's what I would say. I won't say I would not call it best practice or good practice. It is good to have one, especially when you're joining dimension to fact internal sales. Is usually, in most cases, you just need a one direction relationship. So it's very in rare occasions where you want to visualize something in the other table by something in another dimension table that is not directly related. That's when you need to have both relationship with the fact tables that they are both joined to. Yeah.
Yeah, hello, sir. So thank you very much for this section. It's quite insightful. Really appreciate. So I have two questions. So my first question is it advisable to always create your model yourself? Because there's a place where you automatically allow Power BI to create. Because I was wondering, maybe there could be some times when Power BI actually create an error in the creation of the modeling. So is it advisable to always do your modeling yourself? So my second question is, so when you mentioned creating a bridge table between a fact table and a dimension table, so you were like, okay, the bridge table could be a time related table, right? So my question is, between the bridge table and the two fact table, so what relationship? Because it's kind of not clear to me. Like, there should be relationship between the two fact table and the bridge table that you are creating. So could there be could it be that, okay, there will be relationship between the two fact table and the bridge table, or there won't be relationship between the two fact table and bridge table? All right, thank you.
Okay. All right. So the bridge table that I'm talking about, there has to be a relationship between that bridge table and each of your fact tables, right? In this case, for example, this one that I have, fact internal sales reason and fact internal sales. Yes, there is a direct relationship because they both have sales order line number in both tables. But if I want to create a bridge table, or I have a bridge table, a table that has a relationship with fact internal sales and also has a direct relationship with fact internal sales reason, then I can bring that table in between. What is important is that there is a relationship between that bridge table and both fact tables.
Okay.
If there's just relationship between fact internal sales and the bridge table, then you can't, because the idea is that the only reason why you want to join these two tables is because you have information in this table that you need on your report that you want to be able to filter by, or something in your fact internal sales. So you want to create a relationship. So the bridge table that you are creating, must have a relationship between the two fact tables, right? So that's very, very important. Your other question, can you remind me? I'm trying to remember what the first question that you mentioned.
So, like, in creating the model between tables on Power BI, I mean, it's always advisable to let Power BI
Okay,
automatically.
to either do it yourself or let Power BI auto detect relationship
Maybe
for
there
you.
could be errors in Power BI creating sometimes there could be errors.
Of course, yes, there could be error. What Power BI is using. In fact, if you try this, in most cases where you don't have a data engineer and you have your database, maybe the relationship between two tables, they are not named the same way. Power BI would not detect that relationship and will leave it for you. And
Okay.
of course, there are times when you have both tables that you have the same name, but that is not the primary key or the foreign key in the other table, but they have the same name. Power BI will just join them together, and then you would have none of you will not have any relationship. It has a relationship in terms of, the title. So sometimes it's important or it's good that you create your model yourself. And like I mentioned, your data modeling starts from your database. If you're certain and your understanding your database gives you that edge, if you understand your database 100%, sometimes you might not even need to come to this data modeling. You can import your report and start building your report instantly because you know that the data you have imported, you understand the relationship. You know that, oh, if I bring in fact internet sales, I bring in the product, I bring in the customer, I understand the relationship from them is mapped right from your database. You may not even need to come here at all because you would have auto detected the relationship and it's fine for you because you understand your data. So your data understanding will determine whether you should build it yourself or you allow Power BI or you use what Power BI has actually auto detected for you. So, I mean, to answer that question, it depends on how conversant you have with your database or your data that you're working with. So,
all right, thank you, sir.
Yeah.
Thank you very much, Mr. Ademola. Thank you, everybody, for staying to the end of the class. We would have to end the class for today. And next week, we would start introduction to data analysis expression, DAX. We'll bring somebody on board that will do that with us. So thank you very much, everyone. Thank you, Mr. Facilitator. Thank you, everybody. Thank you. Take care and have a wonderful weekend. Bye.
Thank you very much, Benga. Thank you for having me. Enjoy the
Thank
rest
you.
of your evening, everyone.
Thank you.
Yeah.